Afternoon, guys. We're going to get started here. So I'm Zach Grace. This is Brian Genz. And we're going to talk a little bit about some network defense stuff and a little bit of purple team talk here. So where this talk is kind of coming from is I've spent a number of years being on red teams, and basically, you go in and you own the place and you find all these vulns and you hand it over to a team and you go, here you go fix all this stuff, and you come back next year and guess what? Same thing happens, right? You own them and you go, well, why didn't you guys catch this? We did a lot of similar things that we did last time. Maybe the initial vector of getting in is different. Maybe you fished last time and we found a network vuln this time that got us in or whatever, but you didn't detect all the similar lateral movement things that we did. Didn't detect us getting on your domain controller and dumping all the hashes. So what we realize is one of the big gaps you have in current red teams is that the deliverable is really vulnerability focused. It's, hey, let's go fix all these vulns, but you don't really have anything saying, hey, here's the attacks that we did. You should start to work on your detection. So if you take that red team report or pen test report, whatever you want to call it, and you give it to your SOC, they're going to look at it and say, there's really nothing for me to do here, right? That I can maybe start to do some of this research, but it's not very actionable for them. And so what we wanted to work on was, okay, so how can we make that better? We still need to tell them about the issues, about the vulnerabilities, but how do we also give them something else that the SOC team can use to become better defenders?
So what does the blue team need? We need a training partner. There's no teacher but the enemy, right? In front of me. Attack signatures. And basically helping understand when you detect something in the network, understand it through the lens of the attacker, understand the context and what's going on. And the big thing that I think is important and a takeaway from this is better visibility to understand what normal looks like. And Jake Williams this summer was talking about some sort of a TV special. And I don't remember what it was called, but it had something to do with the Secret Service. And they were having trouble training agents that were doing counterfeit detection, and they kept failing in the detection. And what they found was that they didn't know what correct money looked like, what actual legitimate money looked like. When you get out into the street, there's different textures, different feels, different situations. And I think once you translate that into our world, how do we actually know that we know what normal looks like? What is supposed to what's going to spawn this process? And how can we detect something when we've got lateral movement inside of our network? Now, to Zach's point, you might have a pen test report, but for the folks that are doing the detection, where do they stop in this kill chain, in this attack vector, and say, when this jumps over to this machine, here are the artifacts that are created. What normal looks like is this, but here's what just happened.
Yeah, so the goal of what we're trying to propose here is really to reduce that mean time to detection. So if you ask any red teamer, compromise generally is very quick, right? So it can be, excluding the recon portions of things, the actual sending the fish or whatever the payload is happens within seconds to maybe minutes. But detection actually generally takes, much longer. So, weeks to months to potentially never. Somebody posts your stuff on Pastebin, or you get called by Krebs, right? Maybe that's when you know that you've been owned, right? So the goal is to try to take that from, that very long time frame down to a much shorter time frame. And so what we're proposing here is what we're calling the threat detection maturity model.
So some of the background here, we're looking at ways that we can have tighter integration between red and blue teams. So from the blue team perspective, I'm on a hunt team. And again, emphasizing knowing what normal looks like. I think that there's more to that, and there's a lot of different angles that we have to be familiar with what normal looks like in different sectors and segments of the network. And then looking for anomalous behavior, least frequency of occurrence. If we talk about auto runs or shim cache or any number of things we might look at on one machine, how do we scale that out? How do we look at abnormal activities on the endpoints, but do it across all the endpoints. And how do we have the discussions with management to make sure our instrumentation is right, so that we have the visibility into those sections?
Yeah, so from the red team side, we're going to be talking something called threat injection. And the way we're looking at this is a very specific single detectable thing. So a simple example that we're going to walk through later is registry-based persistence. So if you put your persistence in auto runs, next time somebody logs in or boots your machine, it's going to kick you back a shell. And that's an example of like a threat injection. And we're going to talk a bit about the MITRE ATT&CK framework and using that as like a prioritized backlog for things that you should be trying to detect. So the goal of this threat detection maturity model is really, like we said before, to reduce that mean time to detection. It gives a way to objectively measure those capabilities and really track some progress over time. We've seen instances already with this that we're actually able to show some return on investment. So as you invest in new technologies, you gain these new capabilities, you can show your leadership that, hey, you spent that money, here's what we're getting for it. It's been pretty effective for us. And moving on to the MITRE ATT&CK framework. So how many people have heard of this thing? Sweet. So quite a few. It's pretty slick. So when we started doing this threat injection, we actually started making our own lists of like all the different persistence mechanisms, different ways to do lateral movement and whatnot. And then I ended up seeing a tweet by Subti saying, "Hey, I just added a bunch of stuff to this framework," and we went and looked and said, "Oh well, cool. Let's use that instead of reinventing the wheel." So this thing's it's fairly comprehensive. I'm sure there's many others out there, but if we think about the Pareto principle and let's do the 80, basically this should cover about the 80%. It's a good starting point. And sort of the premise of this model is that it focuses on the latter half of the kill chain. So looking at the arrow here, this is their version of the kill chain. And not focusing so much on like how do you get in, but what happens after you get in. The things that attackers do once they're inside your environment that you should use to try to detect that presence. And so here's just a portion of that attack framework, and there's 10 different tactics across the top. So these are kind of categories of things that attackers are going to do. So it's everything from persistence to command and control to lateral movements. And these are the types of things that we should be focusing on getting better at detecting. So out of the 10 tactics, that breaks down into over 120 different techniques. And one of the things that we've been doing is taking these and actually prioritizing them based on our own threat model. So what would work for us for prioritization probably wouldn't work for you. A good example is if you have an organization that's say doing a lot of international travel. A BIOS attack where somebody may take a laptop, rewrite your BIOS, might be more prevalent to you than, say, an organization that is only based in the U.S. and it doesn't have that same kind of attack threat. So these need to be prioritized based on your threat model. And so this is kind of the working model for us, where we've got the MITRE ATT&CK technique as the backlog of the 121 different techniques you can use to do all those different tactics, so persistence, lateral movement, and such. And you go through and you prioritize these based on what it is that you think is most relevant for your organization based on your own threat model. So first thing after you've done that prioritization is you take that out and you build out what's called use case. So many red teamers probably don't know what a use case is. That's more of a blue team terminology. So you got to start to speak the same thing. But a use case is something that a blue team typically would take and use to build out different SIM rules, correlation rules. And so when you're working together in more of a purple fashion like this, you basically come up with this together, right? We're going to talk about different maturity levels and what you want to do. So with the BIOS example, we may not want to automatically detect and respond to that, but the DoD probably does. So in their use case, what they want as their maturity goals can be different than, say, mine. So once you have that use case saying we want to detect, say, BIOS level persistence, automatically, then you go out and build that threat injection. So the threat injection is just going to be that small little attack that actually does the thing that we're trying to detect. So once we've built that out, we can simply go and execute the threat. So if it was a simple registry-based persistence, it may be as simple as, heading the blue team registry file that you run that, and now the persistence is there, and now we can try to go and hunt and find that.
In the bottom square, we talk about adjusting detection methods. Personally, I break this down into if something is an artifact that we should have seen and we had a fail to detect, or we didn't meet the standard that we set out to meet. I think it's really important that we not beat people over the head about this. This is a multi-pronged thing. Is it skill set? Is it instrumentation? Is it other? So when you have a failed detection, do that lessons learned, and we'll see in the example in a few slides here where we come back and say repeat the injection, but this time with more visibility. And to Zach's point, then you can come back and justify saying with this investment, we now had this greater level of visibility and we stopped this attack.
Yeah, so once the attacks are successfully detected, basically need to figure out how much do we want to operationalize these things. So if you want to hunt these things, that's one thing. If you want to make this automatically detected as in your environment, that's something completely different. So the goal is to keep and maintain those. And what we've got here is this repeat injection. So when we've done this at our org, we basically have seen that we'll repeat these over and over again, and it may happen that you don't detect it at some point. And an example is, we've had one where we run it every quarter because that's what we want to do, and we run the first quarter, everything's cool, we detect it, we get the alert, we get the IR response. The next quarter, we do it again, same thing happens. Third quarter, go and do this, and we get no response. We don't get an alert. Our team never knows that need to go take a look at this thing, and we kind of go WTF, like what's going on here? And what this actually has been showing us is that the more we build this out and automate this, we can find where there become issues with our infrastructure. So that particular instance, there happened to be log ingestion issues, so that it didn't reach the threshold that was required to actually trigger that alert. So this is actually becoming more of a QA process for us. So I'm sure that your SIMs are highly complex and they have lots of data getting fed into them, and this can actually help you identify where you may have issues of that data has stopped feeding your SIMs or your MSSPs. And so when we go to implement this methodology, you can do it really in what we look at 3 phases. So the initial phase, just sitting down together with the blue team and let's do that specific threat injection. Let's do this persistence. Okay, can we detect this? Yes, we can detect this in a single instance. Okay, can we now detect this across the enterprise? Yep, we can also do that. Cool. So what happens next? Well, as red team, we get to be sort of nefarious, right? Let's do this as more of a black box, all right? So we're going to do that same threat injection, and let's do it on a box and not announce it. And now, do we follow that same response level? Do we get the full IR response if that's what our goal is? Or do we get that log correlated if that's what the goal is? And as long as that's going well, then we get to kind of move this up into really more of a red team engagement. So the red team come in, do the things that they typically want to do, but we want to make sure that we're still identifying those same types of tactics that we have built out already. And we're going to talk a bit about that more as we get to what we call threat simulation. And so now we're going to get into our threat injection and hunting demo. So we're using a really basic scenario here. Really, it's an efficient email. Got registry-based persistence. An attacker probably is going to dump hashes and try to get that local administrator hash so they can try to do some lateral movement using past the hash. And once they gain that lateral access, maybe they find a domain admin cred and RAM with Mimikatz or something like that. And then they want to go and compromise the domain controller and then ultimately pull out some data. Right? That's a pretty standard scenario.
So in the scenario we have, we simulated a resource-constrained blue team. So we limited it to sources of forensic artifacts being basically NetFlow and local logs. and specifically called out a limited capability for collecting volatile data for live response, essentially.
So the first one, as we're looking at auto-run persistence, it's pretty straightforward. I think most of you have seen this, but basically what we're doing here is we're in the HKLM run. We're dropping in a simple PowerShell script that's going to kick back and get us an agent after somebody has booted into their system. So this is one specific instance. There's a pretty good list here, also at PwnWiki. So we were talking about one very simple one here. There's, I think, 35 or more listed out at that website. So as you think about this scenario and what we're talking through here, we'll do this for one, and you want to be able to identify and scale this, but then not just this one, right? There's also current user and about 30 other places that they can stick the different persistence within the registry, and this is just registry based. There's many other versions of this. But for this example, this is basically our very simple threat injection. We've added that payload to the local machine auto run. And if you're doing this on a single instance, you can use auto runs from sysinternals to try to identify malicious stuff within the various registry-based settings. There's also WMI that you can do through here, and a number of different places that persistence lives. I was at Mubik's talk earlier, and he was kind of giving a hard time to Mark Rusunovich that we keep coming up with all these really cool persistence mechanisms. He keeps adding them to auto runs to make it easier for people to identify. So this works pretty well on a single instance, but obviously as you want to scale this out to an enterprise, it becomes a little bit more difficult. And we're going to talk about how to do some of that in a sec. So the next one that we wanted to focus on was really pass the hash. So has anybody not heard of pass the hash? Nope. Good. So really basic example. We compromised the machine. We dumped hashes, and using this the remote access we had on the system, proxy through interpreter to use PSSEC command to spray and look for a local user that had elevator privileges.
So again, keeping with the scenario of a resource-constrained blue team, we just picked some free tools here. So this is Flowbat. I think Jason Smith is here. So Jason Smith, Chris Sander, they've got some really slick install tools for Flowbat, and there's a Silk backend. We see that one host, the one that got infected, talked to, we're going to call it DigitalOcean.ru. And so this is a GUI, right? But you'll see in just a minute that you have the ability with Flowbat, and we specifically didn't want to focus on tools, but I use this because it builds a proficiency to understand what the queries are going to look like, so that as you do the visual exploratory analysis, you're also going to have visibility on what the RW filter syntax is for the queries. So what we're doing is trying to understand, what happened on this one machine, and keeping in mind in the scenario we only have NetFlow, which will serve to kind of differentiate the scenario for the second iteration that we would do later on. So we want to know, is there any lateral movement? So essentially we're going to look for the destination port of 445, and again we're just putting this in here, but there's the visual, you could build it, zero in on these hosts, and then we're further doing the data reduction. So with that, we'll flip over to the free version of Maltego. And granted, this is a simple example, but we can visualize, talk to other people about .133. It's talking to multiple hosts on 445. And then, this is just showing that if we wanted to, scale this out to 10,000 in a different scenario, we can trace back a lot of different things, but just using some free tools to understand and get a better level of visibility, I think helps us say, okay, here's what we found and what we detected, and what we're able to pivot into with just NetFlow. And then the next thing we'd want to look at is what can we find on disk and in memory, keeping in mind that our scenario, we're using the free tools, we're resource constrained. So this is just a Mandiant red line collector that we threw on the victim system. And certainly we're not here to do a tutorial on doing the forensics on this. So I just wanted to show a few different examples of, here we saw this process ID 568. It was PowerShell exe. We have a time, and essentially that's 8:35 Zulu. So now I'm making a note. I can pivot over, look at other evidence sources. Hopefully everything's UTC. And we see that, PID 568, which was PowerShell.exe, talked out to that potentially malicious DigitalOcean.ru on port 80 TCP. Then we look at prefetch, and we see the times that matched. We see some 4624 successful logon type 3. And then, we take what we can from that. But I think that part of the value in demonstrating what you can get in terms of visibility, if you have tool set A, right, then the first iteration is, well, we didn't have any live response. So the next time we do it, if we're able to go back, have the conversation about resources, instrumentation, training as needed. Now maybe we can have a live response capability and get that critical visibility into the host. So here, just using fresponse to connect remotely to the victim machine, and now from that we're able to pull, the disk, the memory, and do some other more involved analysis of volatility.
So it's cool we do all this stuff, but we still have to report that out, which is one of the issues with current red team engagement reports. So as we start to provide this information back to the blue team, we need to put it into context for them of, here's the things you should be looking for in terms of, this attack that I had. So we performed a pass the hash attack. So this might be an example of what I provide back to Brian here to say, hey, we did the thing. Here's what you should be looking for both locally and on the network level. So we have a couple different places we can look, right? So on the host, you might be looking for Windows event IDs 4624 as a type 3 logon. So that would indicate that came across the network as a hash. And then in conjunction with that, we also will see in this case that a service was created. So we used the PS exec to create a service. So now he's got that data to kind of go back and start to build out that hunting capability to understand that. And in addition to that, we've also got some network artifacts. So he was shown before, where we've got the Maltego, and we start. Okay, so we've got this one host here, and all of a sudden it starts talking to all these other hosts out here. That looks pretty abnormal. And we can see that in the report here that that host 133 talked to every host on that subnet over port 445. So that's something that's suspicious, and that now he can start to look at and analyze from like that net flow level. And sort of the same thing with the registry persistence. This is a little more basic, but basically we've got in that HKey current user auto run that some randomly generated name, right? So if you don't know your tooling, you're using Metasploit, you're going to end up with something like this. That looks pretty obvious, and it should be pretty obvious to anybody who's hunting this type of stuff that this is not a normal key, that we should go and investigate that. So as we start building this out, and we start with that prioritized list and start actually doing these things and measuring how well we can detect this, we can start to build out some fun metrics, and executives love these things. It's amazing. But what this is actually trying to show is these bars represent what we want that capability to be. So we want an instant response when we get a new service created, and they don't necessarily have to respond to it, but they need to review it. So if all of a sudden you get a whole bunch of new services get created on a subnet, and then they get deleted immediately after, like, I'm very interested in that. We should go investigate that. That seems interesting. And maybe it's Bob admin over here just installed a whole bunch of stuff or ran a command across to do that, but we need to verify and validate that. And in this case, we can see that there's places where we have major gaps, and this is where we can start to refocus that effort to tweak and get better at that detection. This is that adjust phase, and now we can actually see what this looks like. And so what this is showing here is basically we can look at this from a training perspective as well for, say, overall capabilities. We can look at persistence or PRIVASC or what have you for determining this over time. So in this case, the green line here makes a pretty significant jump. So that might represent where, hey, we bought this tool and we made this investment, and now we can see what we got for it. That's really showing that ROI. And we see one here, the little blue line that actually dips quite a bit, and maybe that's a whole bunch of new, lateral movement techniques came out. So somebody watched, talk here, and we added a whole bunch more to the threat matrix, and now we've got 10 more that we should be checking for versus what we had previously. So doing the threat injection is that very specific individual piece where we're going to do the one thing, see if we can detect it. So threat simulation is kind of modifying what we've got for our current red team engagements to help us out with giving something to the defenders, the SOC, or the hunt team to try to identify this stuff. And what it really means is that we're choosing specific techniques and tactics that either we know that we've built these defenses out for, or ones that we are untested that we want to try to identify if we can detect them or not. And you may choose to do, say, a specific type of actor or malware. A good example would be, if you're always doing stuff with, say, PowerShell, because PowerShell is cool, maybe next time you do it with net commands and go more old school to just give a different view, and maybe there's slightly different artifacts that come out of that, but we want to suss that out and make sure we're still identifying that same type of behavior regardless of tooling. So just kind of giving a different look here. So, if we were making some kind of report, we may be able to show here on the MITRE ATT&CK framework that, in this particular engagement, we did well at identifying the network scanning. We didn't do so hot at, say, C2. So maybe, in some cases, we're not getting the DNS logs, so you can't actually hunt DNS command and control. So if you're using something like a Cobalt Strike, where you're pumping all the stuff over to DNS, you might not be able to identify if you don't have the correct log sources. And so now we can use this to say, hey, we kind of suck at C2, so why don't we pull those log sources in now and start to do some more hunting on that periodicity of that beacon calling home. So for the most part, I think most organizations contract with outside third parties to do testing, right? It's a good practice. Even if you have an internal red team, you still probably want that outside perspective, make sure internal folks aren't missing anything. And this is where we can work with them to get a little bit different deliverable. So not just a list of vulns and recommendations for you should change your network this way, you should do some more segmentation, you should go fix that Tomcat over there, and really start to get down to, oh, I did a fast hash attack on the network, or we logged in with these default Tomcat creds, or we dumped hashes over here, and here's the ways that you can try to detect this, and really give more evidence to the blue team as well. So I'm guessing most attackers that have heard of a NetBIOS or probably use it on a regular basis, a responder type of attack, NetBIOS name spoofing. Many defenders, I'm sure, have never heard of that, let alone seen that on the network. So if you were to perform that type of attack during one of these engagements, it may be prudent to supply a PCAP showing here's what that looks like on the wire, right? So if you see that name come by, the responder will send out that response to it, and you see that the request come back, and you see the credentials get snagged by the attacker. That's something that most defenders have never seen, and it'd be very useful if you actually supply that and say, hey, here's what we're seeing, and then they can start to look at that from like a NetFlow's perspective to try to identify that type of behavior. So, some recommendations.
This is about measuring, first of all. How are we doing? That's tough for the blue team guys. It's a little bit of an open kimono kind of scenario. You don't want to end up with egg on your face. But I got to tell you, for the red team guys like Zach, we've got a couple of other guys in the room here, the humility and the professional commitment that they have. I've seen these guys walk up to our SOC folks and have a very constructive but very calm and humble conversation with them. And it goes so far because we are all in this together. And I think that this kind of approach, it really goes a long ways to kind of building that rapport and letting folks know that we are not coming here to beat up on you. But at the end of the day, we need to find out what we can see and what we can't see, and just have a basically structured approach to identifying those, line them up and knock them down. And the other point about the blue team, if it's an internal pen test, that's one thing we can talk. If it's an external third party, that's something where we just need to be explicit about saying we need the artifacts from this, by the phase of the attack, however you phrase it, but understanding that we are there to improve the overall security posture, and don't be afraid to ask for what you need from that and get that in the scope of the work. And then, rotating the testing firms or the testers within a firm, I'd even go farther in saying, do some shadowing or whatever you want to call it. Have your hunt team sit with the red team sit with the hunt team, put everybody in a mission room, see what happens. But I think that cross-learning is going to be very beneficial to the organization. And then, use this model to test your security partners. If you have a third-party SOC, let's see what they can see and what they can't. And again, certainly there might be contractual considerations there, but ultimately we're looking for ground truth. It's not who's right or who's wrong. It's what is the terrain, what is the landscape, and are the decisions that we're making and that we're influencing management to make, are they aligned with that reality?
Yeah, so I guess for Red Team, a lot to what Brian said, is really be a partner, right? Don't just come in and be like, we totally hacked you guys, like we dumped all your passwords. And Jason Industry right before us had a lot of good examples of like how you can do Red Team fail, and really putting it out there that you've got to be more of a partner. The whole goal is actually helping people get more secure, not just saying, hey, you guys suck, here's all the stuff that you need to go fix, but saying, hey, here's how you can get better, here's some recommendations we have for you. Focusing on not just the vulnerabilities that are identified, but what attacks were performed on the network, and helping them understand what those attacks do and how they can detect them will go a long way to actually making them more secure, not just reducing the small risk that's associated with whatever the handful of vulnerabilities were that you identified. And one of the things I've noticed like over the years is that you really need to know your tools and know how your tools work and how the OSs and everything like that works as well when you go and do this stuff, to actually be able to provide that type of info. To understand that when you do that pass the hash attack, a new service gets created, and the psexec command actually creates a new service, drops the binary in there. Like, many testers don't understand that like there's all this communication and all these things that happen behind that one line in Metasploit that you set up the module and you run it and everything's cool, and like now I got shell, but okay, so flip it on the other side and look at your own VM when you or your lab or whatever, and you compromise that box and you go, oh, okay, so this is all the things that changed. If you're not very good at the defensive stuff or really analyzing these things, you can use stuff like Cuckoo. Like, you've got a payload, and you're like, hey, I want to see what this payload looks like. Go use something like a Cuckoo sandbox to actually understand what that looks like. And the better you know your tools, you're going to be able to recommend how to detect and defend against them. And kind of the fun thing from my perspective is, the better that he gets at finding my stuff, the harder I have to work to find new and cool ways to get around it, and that just makes everybody better. So that's our talk. Here's a couple of resources that we talked about if you're interested in them. The MITRE ATT&CK framework, I recommend you go out and check that out if you haven't already. And then the Pwn Wiki is a pretty cool place that has a lot of good info about kind of like what the attackers do in terms of perspective and lateral movement to augment what MITRE might be missing. So, thank you. Question?
Yeah, just ran out on that minor. So it gets large, right? Yeah. How are you